So my second IPC interview today is with Matt Kelly. He's just recently been promoted to Chief Technology Officer and VP of Technology at IPC. So congratulations, Matt, and thank you for joining us so far today.
Thanks, Trevor. Nice to see you again.
Yeah. So let's talk a little bit about, first of all, your promotion and where it's leading, because you tend to be getting involved with IPC at a much higher technical level. What's happening there?
Yeah, and it's actually, one of the reasons why we're improving the structure at the VP level within IPC is so that we can actually do a little bit more in different technology spaces. So as our focus areas for solutions moving forward, we're actually looking at 4 different areas. So we have, first and foremost, I know we're going to talk a little bit more about advanced packaging, but we have a lot of effort being devoted to e-mobility, factory of the future, which we've talked about in previous interviews, and design. We know that everything starts with design, and when we are having such fundamental changes that we're seeing in silicon, it's fundamental at the design point. So the point with structuring our technology solutions group the way that we have recently is to make sure that we can actually look at these different areas as requested by our members.
Well, it's very important. There are 4 very important areas, but it's also very important these areas are seen to talk to each other. I mean, for years we've talked in the PCB industry about design for manufacturing, so that it's essentially getting the information and the learning back to the designer so we don't make the mistake again. So being able to join these communities together is pretty critical.
Yeah, and if you think about that listing, it's actually a bit of a strange list. I've had a few people kind of question why we've got it in that order, because if you think about e-mobility, that's actually a market, right? So you're talking about market applications. When you talk about design, that's a fundamental element of process. Factory of the future is really about how things are made and manufacturing based, and advanced packaging is really at the beginning of all electronic change. So it's kind of a mash of different elements, but we know that if we can look at all of those together moving forward, that it'll add value to our membership and the industry.
Right, and presumably you'll look to maybe expand these areas into other areas as you go forward.
Yeah, and it's really about the portfolio, right? So if we look at like the longevity of this structure, I'll just make it up, right? If the demand for advanced packaging, we understand everything, and we're looking at the next technology. It's the structure of keeping on top of the next greatest technology. So it's more about the portfolio of the technologies that we're interested in. Again, that's my job. It's to make sure that we're working on the right things for IPC membership in the industry, and the more that we do that, the more opportunity there is for standards, for education, for advocacy. A lot of our effort, again, in advanced packaging that we'll talk about, over the past year has been advocacy. Kind of fighting for our industry. For the members.
For members.
Yeah, right.
Okay. I mean, because there are, as you know, a couple of other associations that are in the advanced packaging field. So where do you see IPC fitting into that matrix?
Yeah, it's a great question. The one thing that often happens is that silicon gets talked about first, and it's a kind of an obvious start. But if you look at where IPC's legacy is, it's actually coming from the other spectrum, right? So if you think about printed circuit boards into HDI, into Ultra HDI, and now into IC substrates, not saying that that's easy. Obviously there's challenges, but there's a thread that can be drawn between all of them and kind of progressing up into these new technologies. So what we're doing is we're pushing closest to the state of the art that we can. We realize that real intellectual property and advancements are happening inside the companies, but what we're doing again with this structure is to push up as close to the state of the art and leading edge as we can, knowing there will always be a gap, right? So that's what we're doing. In terms of the packaging side of things, again, there's a similarity between EMS, ODM as roots into OSAT, as well as advanced or ultra kind of printed circuit board assembly. So again, while there's differences and changes there, there is a common thread.
Commonality
that's right, and that's exactly what we're doing with IPC, kind of coming from our roots and then pushing up into the value chain, not into silicon, not into the top of
not into the front end stuff. Yeah, I mean, one of the things that the advanced packaging community has been focusing on quite a lot for the last couple of years has been heterogeneous integration. Do you see that as miniaturization continues? Do you see that spilling over into the PCBA world, into the material sets that we use in assembly?
Absolutely, and we're already seeing that. One of the fundamental rules that I learned a long time ago when I was practicing in industry was that everything follows silicon. And we're seeing that now. I would estimate that we're at the beginning of another really nice 10-year cycle in terms of technology development. So with this fundamental change in chiplet architectures and heterogeneous integration, the easiest way that I think about it is in two areas. So one is either going to be direct impact or indirect impact. So for direct, as we've just spoken about, direct impact would be, for the silicon producers in terms of chiplet architectures and, how those compute and memory and storage structures are going to talk. Substrate technologies and OSAT making that component. Those are all examples of direct impact, and that will happen first. But to answer your question, once those types of things happen and new components and modules and ways of thinking are available, that immediately triggers new capability for designers.
Right.
And so what happens then is, in terms of printed circuit board assemblies, ultra HDI structures, and EMS or PCBA assembly, those get smaller, tighter, more difficult to build too. And those are examples of indirect impact. So it's really, just about synchronizing your watch and kind of saying, how long will it take for these changes in silicon and semiconductors to make their way into PCB and PCBA.
Yeah. So. Yeah. Well, the more you get materials that are compatible with each other, then the more you can do with them. The better the tolerances. Final question. There's a couple of people in the industry questioning the term packaging, saying that it's not the correct term because it gets confused all the time with general packaging. And I know that firsthand. At Global SMT, I'm constantly getting calls that are nothing to do with technology. But do you think there is a correct term out there that would describe it?
Yeah, it's funny. I actually just had an email, maybe even as recent as last week, on the same subject. My short answer is no. I think that the term packaging, if you kind of look over kind of a longer period of time, I think unfortunately packaging is going to stick because it's actually an engineering term used by engineers as they produce this stuff. So, we could think up of a new name, but I think that it's going to be tricky to
I think maybe it needs something a qualifier like electronics packaging. It has to be like a double-barreled phrase maybe or something like that.
Yeah, for sure. I mean, we're not talking about cardboard and boxes and those kinds of things. But certainly, I don't actually see the term packaging changing. Okay. I know that's not popular, but I mean, anyone out there is,
No, I'm not arguing with you. I mean, I don't particularly want to have to change the title of my magazine, but, but there you go.
Right.
Just say. So.
Yeah, no, I think it comes down to more awareness in terms of what it really means, and that's part of what we're doing now is a lot more education of what it means and the elements and the components of that. Because quite frankly, a lot of people don't understand how these types of components are made and how important they are. So I think we can overcome that kind of that position of a term that's well used with education. Yeah.
It's very true. I mean, there's a lot of people in our industry that know an awful lot about vertical subjects and not very much about what happens before and after in the process. So anyway, lovely to talk to you as always, and interesting. So congratulations once again on your promotion, and thank you for coming in today.
Thanks, Trevor.
the Arch FX manufacturing platform, processing over 1 trillion data points each month, bringing value to every level of your organization. That's manufacturing insights for tomorrow.
At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important. Expand your inspection capabilities. Inspect in 5 directions using top and 4-angled cameras simultaneously. Find defects that a single camera can't detect, such as OCR and QFN solder bridge. Best in class performance 18 megapixel sensor.